Okay, today we're going to be talking about functions. The rule, the definition of a function is, for each input x, there is exactly one output y. And so what we have here are examples of function tables. Or are they? Let's see. When I put in a 1, I can only get out a 2. So far it's a function because when I put in an x, a 1, there's exactly one output y. It's a 2 every time. When I put in a 2, the only number I'm going to get out on this table is a 3. When I put in a 3, the only number I'm going to get out on this table is a 4. And when I put in a 4, the only number I can get is a 5. So this table is a function. So let's look at the next table. When I put in a 1, I only get out a 2. When I put in a 2, I get out a 4. Well, when I put the 2 in again, I still get a 4. And when I put the 3 in, I get a 6. This one is also a function because for each input, there's exactly one output. Let's look at the final table. When I put in a 1, I get out a 1. But when I put the 1 in the second time, I ended up with a 2. Remember, for each input, x, there can only be one output, y. That means if I put in a 1 the first time and get a 1, when I put a 1 in the second time, I have to get a 1. I got a 2. That means that this table is not a function. For each input, there can only be one output. Okay, here I have a function table. When I put in an x, it's going to multiply that x by 2 and then add 1. And that's going to give me my value. So my rule is 2x plus 1, or 2 times x plus 1. When I put in a 0, that means that the machine is going to take 2 times 0 and add 1. When I put in a 0, 2 times 0 is 0 plus 1 is 1. I'm going to get out a 1. When I put in a 2, my machine is going to say 2 times 2 is 4 plus 1 is 5. I'm going to get out a 5. And when I put in a 3, y equals 2 times 3 plus 1, that's 2 times 3 is 6, 6 plus 1 is 7, I'm going to get out a 7. This is a function because no matter what I put in, I'm going to always get the same answer out. When I put in a 0, I'll always get a 1. When I put in a 2, I'll always get a 5. When I put in a 3, I'll always get a 7. Okay, here I have another function table, but instead of giving me the inputs this time, they gave me the outputs. That means I'm going to have to work backwards. Well, if they had given me the inputs, I would be taking x and dividing it by 6 and getting this answer. But because they gave me the outputs, I have to work backwards. So instead of dividing by 6, I could multiply by 6, and that would give me my answer. Or I could say, what divided by 6 gives me 6. Or we can simply plug into the formula. Instead of replacing x, though, I'm going to replace y with a 6. And I have 6 equals x divided by 6. So again, the question is, what divided by 6 will give me an answer of 6? Well, I would have to divide 36 by 6 to get 6. So let's keep going. Instead of y, we'll say 3 equals x divided by 6. Well, what divided by 6 would give me 3? And the answer is 18. And here we have 2 equals x divided by 6. What divided by 6 gives me 2? And the answer is 12. We can check ourselves. 36 divided by 6 is 6. 18 divided by 6 is 3. 12 divided by 6 is 2. This is a function table. Sometimes they'll ask you to find the rule. Find out what did the machine do to the input to get the output. It's going to be multiply or divide to get started. Sometimes you'll have to add or subtract a little bit to make it work. So let's look. I'm putting in a 12 and getting out a 4. Well, my number is getting smaller. That means I must be dividing it by something. So my equation is going to be y equals x divided by. Well, what can I divide 12 by to get a 4? 12 divided by 3 works. So I think this is my rule, but to tell for sure, I've got to do it another time. So let's say 15 divided by 3. 15 divided by 3 is 5. It's still working. Let's go one more time. 24 divided by 3 is 8. My rule for this table is y equals x divided by 3.